So here we go once again, looking at the problems with special relativity. One of the problems with special relativity is that the goalposts keep moving, and by that I mean, in the case of special relativity, the theory keeps changing from how it's been initially presented. Right, as part of the moving the goalpost, now going to present the pedagogical trick, and that basically means relating to the methods and theory of teaching. This is Don Lincoln. He's an American physicist, and he has put several education videos on YouTube about physics. He conducts research in particle physics at Fermi National Accelerator Laboratory, and the clips I'm going to refer to come from his video entitled "Is Relativistic Mass Real?"
So let's talk about that last one, the idea that you can't go faster than the speed of light. This is a well-demonstrated fact. So why is it true? If you ask a well-educated scientific layperson, they will tell you that it's because the mass of an object increases as the velocity increases. In fact, you'll hear this said by people with physics degrees. There's only one thing. It's just not true. Now, I realize that me saying that is going to confuse a lot of you, like this guy here, for example. So what's going on? Why is it that even some physicists will say that the mass of an object increases as the speed increases? Heck, why is it that even I have said that upon occasion? Don't tell anyone. The reason is a combination of how scientists teach relativity and our intuition at low velocity.
Where he says how scientists teach, that is making it a pedagogical issue. Many texts on relativity say there is such a thing as relativistic mass, so he is opposing what those texts say. Now I want to look at what Einstein Online says in the next slide about relativistic mass. This is Einstein Online, and it says in this second paragraph, traditionally in classical physics, the resistance of an object to changes in its state of motion is its inertial mass. The relativistic mass of an object is defined in the same way, and the value an observer measures for this relativistic mass increases an object moves faster and faster relative to the observer. So according to Einstein Online, relativistic mass exists, and so Don Lincoln is opposing what is being said here. Don Lincoln goes into details about how the relativistic mass concept arose.
So let's get back to the idea that mass increases as you go faster and faster. How did that arise? Well, basically, it boils down to how we physicists introduced relativity to new students. Almost all people who are learning about relativity have taken an introductory physics class, and they're very familiar with the classical momentum equation. So what physicists did was to invent an idea that they called relativistic mass. Relativistic mass was just gamma times the actual mass. If you do that, you can then write the momentum equation as just momentum equals relativistic mass times velocity. That equation looks just like the introductory momentum equation. Taking this approach is helpful when you teach relativity. That way, you can focus your lesson not on new and unfamiliar equations, but rather on big ideas, especially the idea that momentum at high speeds acts differently than it does at low speeds.
So the relevant thing said here was invent an idea. Relativistic mass is not in Einstein's 1905 paper on special relativity. So the educators invented the idea of relativistic mass. It was not in the original theory. It was an idea explaining how to connect mass as used in Newtonian physics with how Einstein's theories using mass. And I'll be going into more details about that later. Discarding the relativistic mass, and you are now discarding how Einstein is connected to Newton via mass. Plus discarding the idea, you're also saying what Einstein was saying was misunderstood or misinterpreted by the educators, i.e. the educators got Einstein wrong. It's not just the case that Einstein could be wrong, but it's also the case the educators were getting things wrong about what Einstein meant. Don Lincoln next points out how relativistic mass leads to a misconception.
But this idea of relativistic mass comes at a price. The price is a misconception. For instance, people might take relativistic mass and Newton's equations for gravity and come up with some silly hodgepodge equations that don't accurately reflect what is going on. For instance, if a particle moving very, very close to the speed of light has a near infinite gamma, I've had people tell me that this means it has an infinite mass, and such a particle passing near the Earth will have an infinite force. This isn't true, but it confuses the heck out of some people.
Right, so what is being claimed now is those who've been taught about relativistic mass have been led to a wrong understanding of the physics, i.e. have a misconception or misconceptions of physics of what's actually happening. I wish to pass on what I think about this because things are far worse than what is being talked about here by him.
Now I should be honest and admit that there is some debate in the physics community about this relativistic mass idea.
Some debate, so he is admitting what he is telling us here is not fully agreed upon, that probably people who believe in special relativity are now believing different things about relativistic mass.
But I would have to say that the majority of physicists who deal with relativistic situations on a daily basis really dislike the concept of relativistic mass.
He said majority, so it's not all of them. The issue is how many people make up a majority. Is it a large majority, or is there a small majority? It could be 80%, it could be 70%, it could be whatever number. So some people are still going by relativistic mass in opposition to those not going by it. So you've got a split now in the understanding of special relativity.
So I suppose that on behalf of physics educators out there, I should apologize for this confusing concept. Relativistic mass is a great way to develop intuition on why you can't go faster than the speed of light. After all, if mass gets infinite, it gets harder and harder to push it, so it has some pedagogical value. But if I may be permitted a biblical reference, there comes a time when we must put aside childish things. And relativistic mass is one of those things one must move beyond if you want to really understand relativity.
So talking about relativistic mass as a childish idea, it can be insulting to those who have been taught to believe in it, because it's implying that they're being childish when they believe in it. He is saying pedagogical, so he is moving goalposts for pedagogical reasons. He's changing the theory. Now, this person is Richard Feynman, and he's won a Nobel Prize in Physics in 1965, jointly with other people. He's considered to have been a genius, and unfortunately he died in 1988. A lot of the things that are taught in physics comes via the authority of what Richard Feynman was teaching, and in this case relativistic mass is one of those things. If we look at what Richard Feynman writes for what he teaches to physics students, he talks about special relativity in this way. He says for over 200 years the equations of motion enunciated by Newton were believed to describe nature correctly, and the first time that an error in these laws was discovered, the way to correct it was also discovered. Both in the error and its correction were discovered by Einstein in 1905. And so he gives an equation now for Newton's second law, and he then goes on to say, this law is stated with the assumption that m is a constant, but we now know that is not true, and the mass of body increases with velocity. In Einstein's corrected formula, m has this value for this next equation, where rest mass is written as m subscript 0, and that represents the mass of a body that is not moving, and c is the speed of light. For those who want to learn just enough about it, so i.e. that special relativity, so that they can solve problems, that is all there is to the theory of special relativity. It just changes Newton's laws by introducing a correction factor to the mass. From the formula itself, it is easy to see that the mass increase is very small in ordinary circumstances. So, according to Richard Feynman, this is what the difference between Newton and Einstein is regards special relativity. And Feynman is one of the greats of physics, and Don Lincoln is effectively saying that Feynman got relativity wrong. Now, Einstein's relativity just keeps changing things, moving the goalposts. It's been misunderstood, mistranslated, etc., and that has been pointed out in my other videos. It was probably also written by Einstein's wife, or at least Einstein's wife probably helped him write it. And so this communication of what the theory is supposed to be has not gone across properly to the mainstream physics community, and they've misunderstood it. It's been a terrible mess made, and they've been teaching their misunderstanding to every physics student at thereafter. Thank you. That's the end.